December 1941. America had just entered the largest war in human history, and it needed tanks, fast. But there was a problem so massive it nearly crippled the U.S. before the fight even began. The M4 Sherman, destined to become the backbone of Allied armor, took over 300 hours to build. That meant if a factory started one on Monday, it wouldn't finish until nearly 2 weeks later. At that pace, America would lose before 1943. President Roosevelt demanded 45,000 tanks by the end of 1943, a goal so ambitious that military planners quietly panicked. The industrial base was unprepared. America was still building cars and refrigerators. Skilled welders were scarce, the machinery outdated, and the production methods painfully slow. But then, a few automotive visionaries asked a question that would reshape modern industry forever. What if we're building tanks wrong? Enter William Knudsen, a Danish immigrant turned president of General Motors, appointed by Roosevelt to oversee military production. Knudsen brought the Detroit mindset to Washington, the assembly line efficiency of Ford's Model T. Tanks were still being hand-built like in World War I, each one slightly different, crafted by artisans rather than mass-produced by systems. Knudsen gathered executives from Chrysler, Ford, and Fisher Body, challenging them to forget everything they knew about tank building and think like automakers. The result was one of the most dramatic industrial revolutions in history. By late 1943, Sherman production time had fallen from over 300 hours to less than 10, a 97% reduction achieved in under 2 years. 13th. Transformation began at Fisher Body. Their engineers realized the Sherman's hull was a single, welded unit requiring over 5,000 individual welds. Welders had to crawl inside the tank just to reach joints, an exhausting, inefficient, and dangerous process. Fisher's production chief, John Alder, proposed something radical. Divide the tank into 5 sub-assemblies: the floor, sides, front, rear, and engine deck, that could be built simultaneously using jigs to hold each part in precise alignment. This modular method reduced welds to 2,000 and allowed unskilled workers to perform tasks that once required master craftsmen. The Army resisted at first, fearing modular tanks would be weaker. But when tests at Aberdeen Proving Ground showed the bolted sections could survive direct 75mm hits, Fisher's system became standard. Their 400-page Simplified Tank Assembly Procedures manual spread across all factories, slashing assembly times even further. At Chrysler's massive tank arsenal in Warren, Michigan, a 1,200-foot-long fortress built solely for armored vehicle production, the new methods reached perfection. Its moving assembly line, inspired by Ford's River Rouge plant, advanced tanks at 3.5 feet per minute through 113 workstations. Suspension at Station 12, transmission at 28, engine drop at 45. By the time the hull reached the end, it was a running Sherman ready for testing. Parallel sub-assembly lines built turrets, tracks, and guns in perfect synchronization. If any sideline fell behind, the entire system stopped. So Chrysler engineered clockwork precision. At peak, 10,000 workers across 3 shifts turned out 1 complete Sherman every 8 hours. 3 per day? Nearly 20% of Germany's total monthly tank output. Ford, meanwhile, solved the machining problem. Sherman turrets required precision mounts, elevation gears, and armor fits accurate to hundredths of an inch. Once the realm of elite machinists. But Ford had learned from building B-24 bombers at Willow Run. Eliminate skill through jigs and templates. They broke turret machining into 23 micro-tasks, each performed by an operator trained in under a week. The process dropped from 18 hours to just 90 minutes. Soon, every Sherman factory adopted Ford's jig systems, achieving nearly identical results. And because each fixture reset measurements, cumulative errors vanished. A worker could produce combat-ready components after only days of training. By late 1942, over 99% of turrets passed inspection after firing 500 test rounds. Proof that precision didn't require master craftsmen, only perfect systems. The next challenge was standardization. 7 different factories were producing Shermans, but without identical parts, chaos would follow. The War Production Board created a master gauge system, physical templates defining the exact dimensions for 340 key components. Factories used go and no-go gauges, eliminating guesswork. If a part passed the gauge, it fit. If not, it was scrapped. This meant a turret from Michigan could fit a hull from California with 0 modification. In one field test, a damaged Sherman in North Africa was repaired with parts from 3 different factories, and every component fit perfectly. By mid-1943, interchangeability was so reliable that the Army stopped tracking where tanks were built altogether. Then came the workforce revolution. America didn't have enough skilled labor to sustain production. The Sherman program alone required 200,000 workers, but instead of waiting years to train them, industry broke complex jobs into microtasks. Chrysler analyzed welding and discovered it involved 47 operations, most simple and repetitive. They divided the work. Experienced welders handled 7 complex tasks, while the remaining 40 were taught to new recruits in just 9 days. Women and teenagers filled the ranks. By 1942, 40% of tank factory workers were women. Rose Monroe, a former waitress, became so skilled at installing turret bearings that her rejection rate was lower than her male predecessors. Workers from age 16 to 70 joined the effort, proving that precision came from process, not pedigree. Behind the scenes, the War Production Board managed a logistical ballet. Each Sherman required 18 tons of raw materials, steel, copper, rubber, aluminum, all arriving on time, or the lines would stop. Every week, 22,000 tons of material moved through 1,400 rail shipments, tracked by telegraph. If a bridge collapsed or a shipment was delayed, alternate routes were activated within hours. This synchronized supply chain was so advanced that decades later, Toyota engineers studied it to design their just-in-time system. Between 1942 and 1945, American factories produced 49,234 Sherman tanks, more than Germany's total tank production combined. By D-Day, Allied forces had so many Shermans stockpiled that divisions could replace losses within 72 hours. While the Germans fielded technically superior Panthers and Tigers, they couldn't match American logistics. A broken Panther might take weeks to repair. A destroyed Sherman could be replaced by the next morning. U.S. generals like Patton fought offensives knowing that for every tank lost, another was already on its way. The Sherman wasn't just a tank. It was a symbol of unstoppable industrial momentum. In the years after the war, the lessons of the Sherman's creation reshaped global manufacturing. Toyota's Taiichi Ohno studied Chrysler's synchronized systems to pioneer lean production. Ford used wartime jigs to revolutionize car manufacturing. The modular, interchangeable, and assembly line principles that built the Sherman became the foundation of modern industry. Critics may say the Sherman was outgunned, but they missed the point. The tank didn't win because it was the best. It won because 49,000 of them arrived on time. The true victory wasn't on the battlefield, but in the factories of Detroit, where engineers proved that the greatest weapon of war was efficient production itself.